Let us take a theorem from the chapter Circle. Tangent segments drawn from an external point to a circle are congruent. Congruent, or they are of equal length. So here we have a circle with center O. We are drawing tangent circles from an external point. Suppose P is an external point. So you are drawing tangents from this external point P to the circle. Okay? Touching the circle in points, say A and B. Now what do we have to prove? We have to prove that the length of these tangent segments from the external point P are equal. Remember students, whenever you are proving a theorem, it is expected by the board that you write the given, the claim, what do you have to prove, and the figure. You get 1 mark for writing the given, the figure, and the claim. And if you do not write these things, and the proof is absolutely right, you will get a 0. That is the board rule. So please keep that in mind. Okay. So in given we will write, in the circle with center O, PA and PB are the tangents to the circle. What do you have to prove? To prove PA is equal to PB. Now for that purpose, what we do is, we join this OA and we join this OB. Now this angle A is of 90 degree. This angle B is also of 90 degree because the radius of a circle is always perpendicular to the tangent at the point of contact. Remember this. Radius of a circle is perpendicular to the tangent at the point of contact. Perpendicular means making an angle of 90 degree. Fine. So you have to remember that, and we have to join OP also, so that we get two triangles OAP and OBP. So we write here now in the proof, join OA, OB, OP. Radius OA is perpendicular to tangent PA, and radius OB is perpendicular to tangent PB. This is by tangent perpendicular theorem. The symbol is for perpendicular, by tangent perpendicular theorem. Okay. Now if they are perpendiculars, therefore angle OAP is equal to angle OBP is equal to 90 degree. Now we consider the two triangles. Now in triangle, I am taking triangle OAP and corresponding triangle will be OBP. So in triangle OAP and triangle OBP, the first thing that we have, if you have a look at the figure, the first thing that we have is OA is equal to OB. They are radii of the same circle. So OA is equal to OB. Reason you will write radii of same circle. Then the second condition, to prove two triangles congruent, students, you need three conditions. So out of the three we got one. The second one that we'll go for is the common side. OP is the common side for the two triangles. So OP is equal to OP We write the reason, common side. Now we are left out with the third condition. The third condition being, we have two angles which are right angles. Angle A and angle B are of 90 each. We have already written this. Okay. So, angle OAP is equal to angle OBP, each of 90 degree. Now we have the three conditions. Therefore, triangle OAP is congruent to triangle OBP, by which test this is, see, common side S, another S, and the right angle. Now for this right angle, OP is the hypotenuse, so it is not SSA test. There is no SSA test, students, please remember. This is your hypotenuse side test or the right hand side rule. Okay, so it is by hypotenuse side test, or we also call it as the right hand side rule, RHS test. Now naturally, if these two triangles are congruent, the remaining elements will automatically be congruent. So remaining element being AP and PB, they will be congruent. So therefore, AP is equal to PB. Reason we write as corresponding sides of congruent triangles, and in CBSE you write CPCT. This is what you had to prove. I hope you understood this theorem.